in this video we will see how to plot the addition of two sinusoidal signals using MATLAB. Not only that, we will actually be working on how to save a MATLAB figure as a high resolution image in PNG format. Now there are a couple of ways to do it, but we are going to take a look at one such method to save any figure as a PNG file in high resolution. So to start, I will go to MATLAB and I will, in the current folder directory, I will create a new script and I will label them this as task 3. After opening, I will have my 3 lines, clear all, close all, and CLC. Now onto the task in hand, it says plot the following sinusoidal functions individually and their additions in a subplot. They say the grid of the graph must be visible, the axis should be labeled, title should be present, sampling time is given, range is given, x-axis limit is given, and here there's a little twist where we don't really have the limits of the y-axis, but we have to determine the limits of y-axis, which should be 0.5 plus or minus the maximum and minimum values of our graph. And then we have to export all of the figures in PNG format, a high resolution PNG format, and we have these functions. Now ft is the addition of sine 40 and sine 70. So let's take a look at this first. And in addition to what we did previously, we will be introducing on labeling the x and y axes, as well as introducing a title for our graph, as well as turning on the grid of the graph. So this can be done in different ways. It's however way you fancy on, you can do it, but here I will break this function into two. So I will call this a separate variable, I will call this a separate variable, because we need to plot them individually and their addition all together in a subplot. That means in one given figure there should be 3 axes present, or 3 subplots for the individual signals and their addition. So I will select sine 40 as one variable, sine 70 as one variable, then I will say ft is equal to the addition of sine 40 variable and sine 70 variable, and I will plot all of those things in a subplot. And first of all, we should define the range is from 0 to 25 seconds at 0.001 intervals. So I will say t equals 0 to 0.001 and 25 seconds. So my time axis is the same independent variable. Next I will tell my first variable is f1, right? F1 is the first function, which is sine 40, and my second function I will label it as f2, which is sine 70, and my final function, which is f, I will call the addition of sine 40 and sine 70. So f1 is sine 40 and f2 is sine 70. Then f is the addition of f1 and f2 variables. Now I need to plot them. Again, one important thing to remember, we should plot all 3 graphs in a single window and 3 separate axes. So we have to use the subplot command. So I will say subplot. Since there are only 3 axes, I will have 3 rows and 1 column. So I will say 3, 1, and this will be the first one. So subplot 3, 1, 1, and I will say plot t f1. Okay, so this is the first one, right? First plot. So in this plot, I need to have the limitations of x and y axis. So I will say x lim. So we know the x limit as 0 to 20. So 0 to 20. But we don't know y limit. So but I will just type the code and I will leave it as a comment, so that once we determine the limits, we can directly come and enter them. Then we need to label the x and y axes. To label the x and y axes, we should use the command called x label and y label. So I will say x label, and you can put the brackets, then put the inverted commas, and inside you can type the text. Right here our x-axis is time, which is given in seconds, and our y-axis is called the amplitude. And then we should display the title. Right, title, again the command is title, so put the two brackets and then the inverted commas. I will say plot of ft. Okay, so title is there, and also the grid of so sorry, this is not plot of ft, plot of f1, and also the grid must be visible. So to turn on the grid, the command is grid on. Okay, so this is all for one single subplot. Now I need to copy this and do it 2 more times. So here this will be my 3 3 3 1 2. So here I will be plotting f2, plot of f2, and then I need another one which is 3 1 3. Now here I will be plotting just f. Right, plot of, I will call this plot of ft. So this is all I need to do, and let's run it and see what we can get. Right, so here I have the figure present. So there are 3 subplots. So plot of f1, plot of f2, and the addition of those two in plot of f3, ft. Now we need to determine the x and y axis limits. So it says we have to add add 0.5 from the maximum and minimum. So here the maximum value in y-axis is 1. So 0.5 plus 1 is 1.5, and here it will be minus 1.5. Similarly, in this place it will be 1.5 and minus 1.5, and here since it is 2, it will be 2.5 and minus 2.5. So I will do the labeling. Minus 1.5 plus 1.5, and lastly I have minus 2.5 and plus 2.5. So next I will run the code again, and you can see all the axes are labeled now, and the limits are set correctly. You can see the title as well, and you can see the grid. There are horizontal and vertical lines, gray color horizontal and vertical lines going in the plot. Now this is for part A, but still it is not complete because we need to obtain a high resolution PNG of this graph that we just obtained. To do that, there are a couple of methods, but I will be using one method, and after plotting a single window, so all these things comes under a single window. So after plotting everything in a single window, I will have the command called print inside brackets. I will have GCF, right? GCF means get the current figure which is being displayed. Then I will have a comma. Then here inside inverted commas, I need to type the file name, that I want to save. So I will say this is plot, okay, ft underscore plot, and this is going to be a png file. So I will say .png. It is crucial that your file name does not contain any spaces. MATLAB and spaces don't go hand in hand together. So it is good practice if you don't have spaces in your file names that you are saving, as well as in your MATLAB.m files as well. If you don't have any spaces, you can always use an underscore to mimic a space. So here I will have the file name ft underscore plot.png. Then I can put a comma. Then I will have to say the type. So here this will be dpng. So this is the type of the file that I'm saving, and I need to specify the resolution. So I will say R300. Okay, so then once I run the code, it will automatically save a PNG file called ftplot.png in the current directory that you are working on. And that is why I mentioned at the very beginning, it is very important to have a proper organized directory, because all the files can be found in that directory, and all the things that we do here, commands like this, printing figures and etc., will be saved to that directory. So I will run it once. So the figure came, and here I'm getting a small error. Say, okay, here there needs to be a small dash. You can correct it. It's dash R300, and I will run this again. Okay, now I got the figure. And after I get the figure, you need to wait around 3-4 seconds, and then I can close this. On the left hand side in the working directory, you can see a new file was created called ft_plot.png. So you can go to the file explorer and double click and open it, or you can click open this file from here as well, and it will open in your default image viewer. So I can say show in Explorer, and I will double click on it, and this is my plot of FT, and you can see it's fairly high quality, and you can use it for your reports and for your documentation purposes, and you don't need to do any extra steps since you have this code. Since you have this line of code, every time you run it, the updated image will be saved in the current working directory. Okay, so all of these were for part A, for ftplot, but we need part B, part C, and part D. It's actually a repetitive process, but for this video I will plot CT as well, because there is a very interesting change that you need to make when you are plotting, because something that we used in our previous task don't work as it is in this task. So there's a small change to be done. So CT is cos t and 0.5 cos 2t. So I will go to here. I will t is common, so I don't need to get t. So I will just take this one line, and I will have some space. We'll paste it. So I have here C1. C1 is cos t. Then here I have C2. C2 is cos, it's 2 cos 0.5 cos 2t. So this will be 0.5 times cos 2t. Then I have C. C is C1 plus C2, and then again subplot is there, and here I will be plotting C1. I don't know the x and y, I don't know the y-axis limit, so I will just have a comment. We can determine that later. Now this is where things get a little bit changed, because when I run this, it obviously gives only one figure. In fact, it should give two windows, right? It should give two windows, but here I only have one window. The reason is we have not used the figure plot command. But here, since we are using subplot, we should have the figure command before the subplot command. It is important because MATLAB knows that all of this, right, what we did for part A should be plotted in one figure. So when we want to plot the figure for part B, we need to tell MATLAB, okay, now we are plotting a new subplot, right? So to tell MATLAB that we are plotting a new window, we need a new window, we should use the figure command. And since we are using subplot here, we should use the figure command before the subplot command. So I will just say figure and have the semicolon. Then if I run it, I should get two figures. Obviously this is not complete, there's still more to go, but now I have two windows. So this is what we want. So what I will do is I will copy this. Don't need the figure part again. I will just copy it. Figure, it's only once per section we need to put. So this is subplot 2. This is the third one. This is just C. Okay. And then when I run it, I should get two figures. Okay, so this is my second figure. And here also you can see plot of C1, plot of C2, and plot of C, which should be CT. But the y-axis limits are not defined, so we should define it. So here 1, so it should be plus 1.5 and minus 1.5, and here it should be 1 and minus 1, and here should be 2 and yeah, we can use 2 and minus 2. It doesn't really matter, but we can use 2 and maybe minus 1.5. So okay. Okay, now the axis limits are almost okay, but here there's uh, no real issue apart from a slightly bigger gap here, but it's within our boundaries. Next, what we need to do is we need to save this also as a PNG. So after this plot, what I will have is this code. I will copy this. So now first plot is done. So this is the next window. So I will have this code. I will change the file name because now I'm not plotting FT, I am plotting CT, but all the others will remain the same. So I will run this code once again. So now both of my plots came, and now you can see in the working directory two PNG files are there, one for FT and one for CT. If I open this in the Explorer, I can actually open these two files side by side and just show a small comparison. Here you can see I have the plot of C1, C2 and plot of CT and F1, F2 and FT. And this is a very efficient way to actually plot figures and extract the figures in PNG format, which is also in reasonably high resolution. Last thing to mention is this code. So this is only for part A and part B. So if you write for part C and part D accordingly, this code will be long. And for lengthy MATLAB code, we can actually break each section down. So if you go to the editor tab, and in the editor tab, you can see something called the section break. Right? Section break mainly separates one section from another. The advantage is you can run the entire code or you can run a specific section of the code. So you will get only the outputs related to that section. Now, since we have part A and part B, I will separate those two using a section break. So here I have part A, so starts at here, then I print it and this is where it ends. So for part B, I will insert a section break. So you can click this button, it will insert a section break, or you can use 2% signs and it will automatically insert the section break. So it's very easy. And now if you see, you can just click on two sides, and on the left hand side there is a blue color line appearing as to indicate which section you are currently working on. So now I'm in section 1, now I'm in section 2. So here I can actually select this section and I can only run this section. So if you see here, run section, so you can run it. Right? When you click that, it will only run the active section and I am only getting one figure as the output. Same thing, I can select section 2 and then I can say run section. Then it will only give me the output for section 2. Here you can see. But if you want to run the entire code, of course, you can click the run button and it will run the entire code and it will give you both the figures. So this is how you can plot the addition of two sinusoidal signals in MATLAB. And not only that, we learned a lot of things about how to plot subplots in different environments, as well as how to use the figure command in this environment, and the x-axis labels, y-axis labels, the title, the grid, and also most importantly, how to save any MATLAB figure in high resolution PNG files. And in the next section, we will again continue this sinusoidal functions a little bit, where we will see how to plot a y equals a sine omega t form function using MATLAB.